So welcome you all guys. This topic, let us try to understand what is basic logic gates. Okay. So let's discuss what are logic gates. Okay. So here you can see the logic gate diagram. So I'm giving an example of AND gate. Okay. So it is basically a basic building block of digital circuits. It has two or more input signals like here you can see A, B and many maybe and only one output signal like here Y. So A and B can have values as zeros or one because they are the binary values. So you can't have 2, 3, 4, you can't have these all things. And output also same thing like zeros or ones. And how does the output depend? You may be wondering. Like output depends on logical combinations of the input. That is logical combinations of input. Okay. So like if this is an AND gate, then it just multiplies A and B. If it is an OR gate, then it just adds the input signal. It depends on the what type of gate it is. Okay. So let's move towards the truth table. So what is the truth table? Now suppose I wanted to know the value of A is 0 and value of B is 0, then output is, so your AND gate then multiplies, right? So it is 0. Later part you will understand what is a really AND gate and NOT gate. Or so here if A is 0 and B is 0, then output is 0. And if A is 1 and B is 0, then output is 0. So now you understood that these are the output. But how many combinations can we make of this? So this thing we represent using truth table. Here you can see A is the input and B is also input. So we can have four combinations. Okay. And the output is the corresponding values of the combination. Like for 0 and 0, the output is 0. And for 1 and 0, the output is 0. In that way. So now the thing is, how many combinations can we make? If there are two variables, we can have four combinations. Okay, and if we have three variables, we can have eight combinations. Now, how to generalize? So here you can see for n input signals, we can have 2 power n number of combinations. So that thing we can just verify. See, if we have two variables, then what is the value? 2 power 2 is 4. And if we have three variables, what's the value? 2 power 3 is 8. That's what I have said here. Like three variables means maybe C, you can see in the logic diagram, maybe we have C, or if it is four variable, maybe it has some value as D. So some input may be there, but the output is only one. More detail you will understand in the later part. Next we'll discuss about basic gates. Basic logic gates. How many types there are? There are basically three logic gates. One is AND gate, then second one is OR gate, and third one is NOT gate. Let's focus on detail part. AND gate. So what does the AND gate do? It just logically multiplies the input. Okay, so here I'm showing the diagram. This in previous section also I show the same diagram. What it does? So AND gate, the output of AND gate depends on the logical multiplication of the inputs. Like here the inputs are A and B. So what the AND gate do? It basically multiplies A and B and store it in Y. So here you can see. And if A is 0 and B is 1, then what is the output we are getting? 0. Because 0 into 1 is 0. Let's see the truth table for more information. Here truth table helps us. You can see all the combinations. So what suppose if A is 0 and B is 0, then what's the output? That way. So you can see 0 into 0 is 0. 0 into 1 is 0. 1 into 0 is 0. And 1 into 1 is 1. This way we multiply. And suppose you take like if there are three input, like we have C, A, B and C. Then what's the output? We just multiply A into B into C. That's all. 3 element 0 or something that kind. So we get another column and there will be 8 combinations. Logical equation of AND gate is y is equal to A into B for two input signals A and B, and y is the output. So these are input and this is output. Okay. So let's move towards the OR gate. OR gate. So what was AND gate doing? Logical multiplication, but OR gate will do logical addition. This is not a normal addition. This is logical addition. You will understand in the coming part. So you can see the logic diagram. Okay. A and B are the input and Y is the output. It's the same thing, but the logic gate representation is different. So what is the output here? Y. Output Y depends on logical addition of the inputs A and B. So we can have also another variable if three variables like C. It depends. Now let's see the truth table, then you will understand. If A value is 0 and B value is 0. So we are doing just logical addition. So 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is 1. You may be wondering how it is possible. Because in the previous part I said it can have 1 or 0. So your A and B and output, all the three can have either 0 or 1. That's what I'm saying here. So we can't have 2, 3, 4 such things. Here what happens is 1 plus 1 is 1 itself. And if I 3 inputs, then 1 plus 1 plus 1 is 1 itself. This is what we are representing. But how? You can imagine like you have connected a bulb to a battery, okay? And there is another one battery, okay? And suppose here is a switch and here is also a switch. And if you off the both the switch, both are in 0. 0 and 0 is 0. Here the same we are doing here.